Okay, so we're going to start our actual debug session, right, by starting to step through main. So my cursor, you can see from the data ref line up here, and then in main is actually sitting at this line right here. So we're going to set a breakpoint at that line by hitting F2. You see the little B's popped up there, so we've set a breakpoint, and I'm going to hit F9 to execute to that breakpoint. Okay, so you can tell we're there because it'll highlight this address for us. If we also look in the instruction pointer register, it's pointing at this memory address right here. So we can continue to step through main until it goes into that subfunction that we found. So we're going to hit F1 to do a single step. Okay, so here we are about to jump into that subfunction we found. So we're going to hit F1 again to step into it. If we wanted to step over it, we would hit F8. F8 is, step next, but jumping over any functions. So we're going to hit F7 to step into. So now we're inside this function that we know uses our string to do some kind of operation. We're not too sure what yet. There's also another function called before that. And then later on in this same function, there's calls to socket and IO control and a number of things like that. Actually, there's another function being defined right here. That's probably where main is going, or sorry, our MSF1 is calling this, which is actually this function right down here. So just to make things a little bit easier, we're going to go here right to this line. Or another way to do it is if we were sitting at that function call, we could just hit enter and it would bring us down to that line. Again, we don't know what this function does, but if we see here calls to socket and IO control and another call to IO control. There's also a print statement down here that's printing out the word MAC and a semicolon. Given that this function tends to have some networking related function calls in it, maybe we can assume that MAC in this instance means like MAC address, as in the machine's hardware address. So if we drill down into this a little more, we could maybe figure out this is something to do with networking. We don't know what it is. So again, we're going to define a function here. So hit capital V to go into the graph mode that doesn't exist yet, and we hit DF to define a function. Again, we don't know what it does, but we're just going to call it some kind of networking. We don't know what, but it's as useful a label as any right now. All right, and then now we're going to run the function analysis. Networking. Okay, so now it knows it's a function, has apparently a ton of local variables. We can also pull up the graph view now and see what this thing's doing. I can see a branch going way off to the side there, so there's likely some pretty serious flow control going on here. So we can see, again, the call to socket, IO control, then we drop straight down here. So this is likely the top of a loop. We drop straight down here into some kind of comparison that does some work with stir copy and IO control. We go down a little bit. It's more calls to that. Here's some kind of loop that goes back up to the top. So evidently we're looping over something, maybe some data that we're fetching. Go down a little further. Mem copy, a print statement. So this is the print statement that prints the MAC. Or prints the term MAC. So maybe some of the, again, we don't know until we step through this, but maybe some of the code above is actually fetching the machine's MAC address and printing that out. It could be. We're not sure why. Well, yeah, we're not sure why. After it prints the MAC address, it drops down here into some if statement check that actually looks like maybe a little bit of a for loop because as long as this is true, we're going to keep iterating over whatever this block of code is. And if you can see here, we're actually doing a %x and a semicolon being fed to printf. %x being the format specifier for hexadecimal. So we saw earlier, just so you can see it on the sort of terminal line here. I'm just going to zoom in. We saw the string MAC being printed, and now basically a bunch of hex digits being followed by colons like that, right? That's at least how this appears to me. So we scroll up a little bit. So what might be happening here is we're fetching the MAC address from the system and printing it out. Right? Why we're doing that, I'm not too sure. We are in a malware sample, so who knows. we're also printing some kind of, oh, so this is probably printing out the various bytes inside the MAC address and maybe printing the last byte after the end of the for loop. And then we kind of, after we've printed that, right before the end of the function, we go into sort of this series of what looks like nested if statements, where the two blocks right at the bottom, we either set AX to 1 or 0, and then we return. Recall that AX is the return value from a function in assembly. So I guess if we keep failing these if statement checks, eventually we would boil all the way down to returning the value 1. Otherwise, if any of our comparisons are ever true or equal, then we would drop down here and we return the value 0. So it looks like what would be important is this function overall returns true if all of these checks pass. And we know that earlier on we were retrieving the MAC address. So maybe we're doing something with that value. So it would be interesting to see what we are comparing. What is interesting is if we look up into some of the print statements from earlier, right? We were printing like the local variable 461, so that was probably one of the bytes out of the MAC address maybe. And if we look down here, variables within a couple of bytes. So maybe these are various bytes out of the MAC address that are being compared, possibly. If we could set a breakpoint in these and run to these. Or we could back up. We'll just roll back to MSF1 and we'll quit out of our visual mode. So we know that this sub function does some kind of networking call, then something where it's using that string that we found before eventually returning back into main. We can also kind of explore maybe a little more what this use string function does. So we know it's decrypting a string. It's comparing the results of that string to the likely to the output of whatever this command is here, this process list. And it seems to be sort of iterating maybe over the results of that process list and comparing a string or maybe a few strings to the results of that before eventually returning. Oh, interesting. This is neat. Just below that function, there's actually another function right here that calls sleep. That might be important. We'll maybe check that out a little bit later. So if we keep rewinding and we go back even further to main, and we look at our call graph or our flow control for this, we see main coming in here. It calls MSF1, which we know does some like function name comparisons out of a process list. It does maybe just some kind of comparison against a MAC address, and then if this is going to end up being, I don't know, based on some return value out of this function, we could drop down into here, or we could go here where we decode another string and start doing some processing. Maybe this is the actual operation of the malware because we keep decrypting text and maybe doing some work. Let's check this out and see where this goes. So it's function 567D. So if we quit out of this, and here, 567D, let's see where that goes. Oh, this is that function that we saw earlier that calls sleep. So let's have a look at this. So if we fail a bunch of tests in main, we get dumped into the sleep function. So here we might as well call this, we'll just define a function here, df, well, I don't know, just call it sleep, and analyze the sleep function. All right, let's see what happens here. Enter the function. We have some comparison of some local variable that's being set to 0 against a massive value. This looks like max int or bigger. So we have something that's initialized to 0. We're doing some huge comparison against that value. If they're not equal, we jump over here. Eventually we're going to add 1 to that value, but we also call sleep with the value 1. So we're going to sleep for a second, increment this counter, and go back. So it's basically, it looks like a for loop that iterates this many times, calling asleep for 1 second every time, and eventually when it's done, it's going to bomb out and leave this function. So if we go back a little bit, we're just going to hop back to main for a second here. I'll quit out of that. So if we look at main, main says, hey, we're going to run some kind of network check and do some decoding and process list checking. And based on the results of that, you might get dumped into this function that just sleeps almost forever and then eventually calls exit. Maybe this is some kind of a check for, I mean, if we were looking at a sample of malware here, maybe this is some kind of check to see if the sample itself is being analyzed. Right? Otherwise, maybe it goes over here and does executes the actual payload or whatever it is. So just to confirm this, we'll hop on over into this function, this MSF1, that maybe seems to be doing some interesting checks. We kind of have maybe a rough idea. This networking function seems to be pulling the MAC address and comparing it to stuff. One of the common sort of anti-debugging tricks is to look for something like fixed MAC addresses that virtual machine software uses. So maybe like VMware or something like that. If they're checking to see if the MAC address is one of the ones that's assigned to VMware, so it knows in a virtual machine, and then it would dump us out into that, forever looping sleep function. But this function we hadn't quite figured out yet. So we know that it's accessing that string we saw from earlier and maybe decrypting it or decoding it. It's pulling a list of executing processes, and then checking to see if maybe that string we pulled is in this list of processes, which is interesting, because based on that, it's going to execute and do something. We're not sure. But just to validate what we think, let's set another breakpoint, because we know this function is going to get called. Right to... Maybe after this, there's a little for loop here that seems to be looping over and doing some decryption operations. So maybe if we set it right here or after this loop ends. So I'm going to go ahead and set a breakpoint right here. It's the line right after that loop finishes. So setting a breakpoint there, and then hit F9 to continue execution. Remember, we're paused somewhere up in main right now. Okay. So we continued execution down to this point. Maybe step a couple more times. Oh, maybe we didn't quite reach that breakpoint yet. So again, we're going to go and throw our breakpoint right here and execute to that breakpoint. Good. Now we're actually sitting at that breakpoint. Let's go back and see what happened. One of the things you'll notice too is that Radar will actually sort of dynamically update sometimes the strings and references for you, which is kind of cool. So it actually changed that EVS var string we had before to Radar2. So maybe that string actually decrypted to that value. Interesting. If we maybe run the analysis once more, see if we find anything useful in strings. No, not yet. So we did see that maybe decrypting into Radar, which is interesting. We know this thing appears to be pulling a list of executing processes, and maybe it's comparing or looking for this as a substring in there. So maybe it's trying to do some kind of debugger detection. Right? We can kind of drill into this because this seemed to have been looping over maybe more than just the individual characters. And so we can actually have a look at that. If I want to do a formatted print of maybe 10 characters from EVS var, EVS var, sorry. Right, so there's Radar right there. But based on kind of what was happening here, I see this, some of the operations that's happening to AX up here and grabbing the address of this string, adding it to the contents of AX, and then pushing it off to this decode. It might be that we're not actually decoding an individual string. Like that is probably calling decode on the entire string. But if this is iterating, maybe we've actually got an array of strings here. Again, that kind of goes with something we thought maybe we had earlier when we were looking at the list of the strings in the data segment. There's that encoded string, but then there's another one right after it. So we can kind of get Radar to try to see if we've got a series of strings, maybe an array of strings. It's not great at recognizing them right off the bat, but we can kind of help it along a little bit. So here's the string that we're interested in, or here's the symbol or function, whatever you want to call it, that we're interested in. So maybe there are a few strings here. Something we can do is we can say do a formatted print of, you know, maybe strings of length 10 that are null terminated from stir EVS for. Now, if we think maybe we're looking at something that's like a string array, what we can do is basically tell it to do this a bunch of times. So we put something like 5 in curly braces. So it'll look for 5 consecutive null terminated strings where each string is maybe length 10. So if I hit enter, interesting. So it found radar, then R2, which is actually an alias for radar, and cutter, which is a GUI for radar. I've actually got it loaded up with this sample in the background here, if we want to have a look at the visual mode later on. So it seems to be looking for the names of these functions in the output of this PS command. So all 3 of these strings were somehow encoded or encrypted before in the earlier string segment, in the data segment of our application. So neat. It's looking for these, and then we can probably assume that if it finds the names of these debuggers, it's also going to dump us into that sleep function, right? So that's maybe an indication that this is another anti-debugging feature for this program, right? So we could actually we know that like our string use is actually checking for debuggers, or at least we think we're hypothesizing. So we look. So if this thing is checking for debuggers or MAC addresses, and then it's jumping down to sleep, then we see this jump right here that actually hops over sleep and goes and executes this code. So maybe this is the part we actually want to be running to see what the malware is doing. So what we could do is maybe change the opcode here from jump of equal to jump of not equal. So we could position our cursor on that jump of equal step and change the opcode. All right, let's sort of like patch the program as we're debugging it. Because remember, we're actually stopped down inside this call MSF1 function right now. We've just decoded the strings that's about to compare them to a process list. So that's actually where our debugger is frozen at the moment. It's at this instruction right now. Right, so the next thing we're going to look at is how to sort of live change an instruction while we're in a debug session. So if we want to sort of live patch this code, again, we know we can just sort of change the direction of this jump, or we can change it to jump of not equal, because we're probably going to fail that debugger check since we're actually running radar. You can actually just let the sample continue to execute if you want to explore that little trap a little bit more, but we're going to jump over that. So to assemble, sort of replace an opcode, we assemble it, right? But we got to be a little bit careful because it's not like we can shift all the contents in memory, because there's various references and jump tables and things like that. So we need to make sure that the opcode that we replace it with is of the same length. So typically jump of equal and jump of not equal are a single byte. So we can say write assembly, and we'll just type the instruction that we want. So we're going to jump if not equal to, actually we can just put this right there. Okay. So you'll notice it went to 7.5 from what it was earlier. So now if we fail the checks, we're actually going to jump over the sleep and continue down into here. Just to see this happen, I'm going to set a breakpoint at that line, and I'm going to continue execution, which should run us up to that breakpoint. Okay, so we're here. We're going to step. It's going to hopefully jump for us. Yep, so it jumped over that sleep call, so we kind of successfully evaded the debugger detection, which is great. So now it's going to go on and continue executing the rest of this program. I'm curious to see what we get after we do this sort of decode operation, and then we're going to dig into this, which is making all these curl requests. While we're here, might as well define a function anyway. I'm just going to call this curl stuff, because again, we don't know what it's doing, but hey. hop back to main for a second. Let's have a look at our call graph at this point. We can rename this in a few minutes to something that's obvious, like maybe we, you know, check for analysis or check for debuggers, because there's that sort of sleep trap function. But now we know that if we pass that, we go over here, we do some decryption or decoding of strings, and we do some networking calls with curl, and then eventually we exit. So it'll be interesting to see what's happening over here.
I mentioned one of the things we might want to do is to start renaming some of the functions once we have a better idea of what they do. So for example, this call MSF1 function that we had been analyzing that you know, looks for process names of debuggers, or maybe checks MAC addresses for virtual machine MAC addresses. Now that we kind of know what this does, we could maybe call it something like, you know, check debugging or something. So I can enter this call MSF function again by positioning it at the top where my cursor is, hitting enter. Now I'm inside that function. And if we pull up our sort of command terminal by hitting colon, if I'm not exactly sure which instruction or command I want, I can hit A for analyze, or the first letter of any of the different command sets. If you don't know any of the commands, you just hit question mark. It'll bring up a list of all the possible commands. And we want some form of analysis, because analysis also allows us to do things like renaming. So if I hit A and question mark, I get a breakdown of all the analysis functions. Okay, I probably want something related to analyzing functions, which would be, you know, renaming, things like that. AF question mark, right? And now I have a further breakdown of all the types of analysis we can perform on a function. So if we look here, AFN, and take some name, rename the function at address. That's probably what we want. So we're in this function, we're right at the top. You can say AFN, the name that we want. Right, so we likely just want to change MSF1 to something like check debugger. Right, so notice that up here my function name changed to check debugger. Now if I go back to main, pull up our call graph. Right, so now we can see that it's called check debugger. Now this is starting to make a lot more sense, right? We go in, we have a call to check debugger. If we fail that, we go into this really long sleep routine. If we don't get flagged as running a debugger, we then drop down into here where we do some decode and some curl stuff. Sort of the last thing to do here would be to figure out what the decode and the curl stuff are doing. I will leave this as an exercise for you. What the sample is doing is not destructively malicious or anything. It's just fetching an image from the internet. So it's safe to sort of allow it to run. So try to see if you can get to this point as well, where basically you've, you know, got general names for most of the high level functions. You've managed to jump over the call to sleep, or change the jump rather, so that if you are running in Radar, or you have that process running, that it will actually bypass that and go and run the actual code. Okay. The one thing that's not particularly great about debugging in Radar, other than, I mean, if you're not comfortable with using the commands and navigating in this way, it's a little bit less visual, but also sort of the project saving features are a little bit broken. You're supposed to be able to do things like save your project and then reopen it. Although I've noticed that whenever you reopen it, a lot of the like references to certain locations tend to be broken, things like that. So it's not great. The project works really, the project features work really as long as you're not closing the project, which is almost useless, except if you don't want to be flipping back and forth between this window and another window. The one thing that does work, you can say like, save this project as, you know, debug1, and then if you want, you can sort of add some working notes. So if you say pn and then the dash, it brings up whatever you have configured as your default editor, and you can type in some notes. And now if I type pn, it will show me any of the notes that I've entered for this project, and I can say ps to save it. I can type P to list my current projects. But again, it's if you close this and then reopen it, you'll see it doesn't necessarily reattach well. A lot of the references are off. You could probably force a lot of the memory references and things like that to align properly, but generally this feature is regarded as being a little bit broken. So the only useful thing is, I guess, if you just wanted to make some notes while you're working, that still will be there. So I'm going to go ahead and exit this project now just to show you what I mean. I'm going to hit Q to get out of visual mode, and then Q to get out of the original sort of terminal mode. It says, do you want to quit? Yes. Kill the process? Yes. And save? Sure. And so I could now go and reopen this project. Right, so I can list my various projects. We had debug 1. So you can actually say project open, debug 1. It asks if I want to close the current debug session. Yes, because it's going to sort of open it again and reattach. Yes, and then we get all these errors about not being able to find certain memory references and things like that. But the only thing that is still here are my notes. So if you do need to get those back in case something crashes, you at least have that. But even if I run the function analysis and list my functions, we're at main right now. You go to visual mode, you'll notice there's like nothing here. So it does kind of get corrupted on reopen, which isn't great. So that's why we're going to move on to some other debugging platforms. Again, Radar's pretty good for some things, but definitely not the standard that most people use. A lot of people like to use IDA. I did also want to show you, before we finish up with Linux ones, sort of the GUI version of Radar, which is Cutter. Okay, so with Cutter, you can open, select a file, go to malware, debug, we'll open that sample. Right, so here it is. It's sitting at the program's entry point. This is the graph tab. It's basically a front end for all the features you can actually use and access in Radar. So if I double click on main here, there's the main function that we were used to seeing before. Again, here's this call to what we have identified as our debug checker, the sleep function, that decode function, and then the curl. You'll notice that it actually does a little bit more work in renaming some of the functions for us. Like, it already identified this one as maybe a sleep function, likely because it calls the system's sleep implementation. By the way, you'll notice I just double clicked on the call instruction and it went into that. Right. Other things we can do, we can rename the, right click and rename the function here. So we know that this was check for debuggers. Right. Actually, this was the MAC address one, sorry. Right, this was the one that checks the process names. We also have tabs down here to access the strings in the various locations, imports. There's actually a Jupyter notebook if you want to go ahead and script, because Radar has bindings for Python, so you can automate a lot of the standard processes you might use in Radar. When it comes to debugging in Cutter, it's pretty similar, right? So for example, we're here on that first instruction in main, and we can start emulation. So for example, if we want to start emulation, we could go to maybe an instruction that we want to see. So here's that check MAC address function. I can right click and I can go to debug and add breakpoint, right? And then now we can actually step over step, continue until syscall, just do a regular continue, which should run us up to this breakpoint. We can also stop emulation. So if I hit continue, here we go, it's executed us up here. You'll notice it changed color to red. So now we're sitting at this instruction right here. You've got all your stack values and registers on the right here. You can kind of pull that window up if you need to. Right? We can look at the backtrace to look at the chain of function calls. So we're like, which stack frame are we sitting in, for example? And then we can just continue to step normally through this check MAC address function. And you could let this thing run. Now what's going to happen here is I'm going to get stuck in that sleep function that runs forever because
I'm running Cutter, which is one of the problems that it looks for. So at this point, this program is just going to halt and sit and sleep forever. But that's it. That's basically the GUI version of debugging from Radar. It's not bad if you prefer sort of this visual approach to things. Right. You can halt emulation just by clicking the stop button, and we get dumped back into our regular application. It is a little bit nice because sometimes in Radar you might get a little bit stuck, and restarting emulation from inside Radar is kind of a pain. It's often easier just to close Radar altogether, reopen your project, but then you lose all your renames and stuff like that. So maybe this is a somewhat more clean approach for actually a more long-running project. And yeah, that's Cutter.